Hello, my name is Jacob Beauchamp, and this video will be a quick code overview of my database's final project. So, we'll get right into it. We can start here with the imports. The DARS check Python script is the main application, which requires a few things. It requires the parse DARS module, which is over here, that I'll get to in just a second, as well as the SQLite 3 API, the system library, and the operating system library in Python. The parse DARS library requires a few of its own, the beautiful soup4 library and the regular expression library. Any of the modules that will need to be downloaded will be included in the README. But now let's get on to the actual application. The application itself is simply just calling the main loop function, which we'll go over now. The main loop does a few things and a lot of user input. First, it checks all of the arguments at the command line level. If we get less than 2 arguments, which is to say no file names, the user is prompted on running to enter the name of the DARS file that they would like to use. If that isn't the case, and instead we have too many file arguments passed, then of course that's an error and we can't really work with that, so the program exits and tells the user that they passed too many arguments. And if we have exactly the right number of arguments, we still aren't exactly done yet. We have to check using the os.path.isFile function on that file name to make sure that it's an actual valid file that we can open. And if all of that passes and we don't error out, then we can actually get to using that. And so we'll pass that into the getNeeded function in the parse DARS library, which, as we can see here, it takes a file name, it opens it, and then makes a function, or not a function, but a parser for it using the beautiful soup library. We have 2 arrays here, one for the raw data for the classes and for the clean data. So the raw data is different from the clean data in, as we can see here, a few things, mostly just parentheses and additional spaces. And the raw data is extracted by looking for this specific tag in the DARS report. Any courses that it finds are appended into the raw data, and then we iterate through it, chop off any parentheses, and reduce any spaces so that there's only one in the course code, which keeps with the convention of our database, which allows us to use the database in conjunction and don't have any issues. We then return that to the caller and get back to our main function. The next thing of note after we've got the initial logistics out of the way is the status update function. We create an empty array called statuses here and pass it into status update, as well as our not taken vector here that takes in all of the data from the parse function, or the getNeeded function rather. So let's take a look at what that does. Status update here, the main thing it does is it opens a cursor to our database and allocates itself an array that we can use for the requirements. First thing we do is grab all the requirements out of the database, and then we put them in that vector. And then we can iterate through that vector now that the requirements are here, and then we can, for each of them, make a little array for their courses, and we'll make a counter that will be the total for hours taken so far. Then from there, we will query the database once again on that requirement name. It looks a little weird that it's in a tuple here by itself, but that's just what the SQLite API requires. So if any given course in this that is resultant from this query is in the not taken list, or rather is not in the not taken list, my mistake, then we add the number of hours that that course has to the taken hours counter. And then we check at the very end If we have more or less, or more or equal to the number of hours that the requirement demands, then we add to the status vector the name of the requirement as well as true. Of course, if we have less than the number of hours required, then we add false instead, but still have the name of the requirement. Lastly, we close our cursor. The next function worth mentioning is the check requirements function. This function is almost identically to status update, except it differs mainly in how we handle whether the requirement is complete or not. As we can see here, most of the code is exactly the same except for this. Rather than dealing with the status vector, we simply print to the terminal and tell the user if the requirement has been completed or not. This is because this function is callable from the menu and the user will see it, whereas status update is called automatically and runs in the background. As with the last time, we start with opening our cursor and connecting to the database, gathering all of the requirements, getting every course for those requirements each, checking if enough of them are taken and so we have enough hours, and then print the result accordingly before closing the cursor. The function corresponding to the next menu item is the lookup requirement function. Much like the previous ones, this one starts by opening a connection to the database and opening a cursor in that database. Since this is another function callable by the user indirectly via the menu, as with all of the remaining functions I'll be going over, this one will have some element of user input. So, this one prompts the user to check what the requirement name they're looking for is. Then we query that in the database to get the name of the requirements and the hours from the database for all requirements, where the name is the name they searched and the major is computer science. The major computer science is hard-coded mainly for scope reasons and to keep the project manageable, as to handle multiple majors would have required a significantly larger database and much more work. So to keep it manageable, we made the decision to only focus on the computer science major. So, as we iterate through the SQLite object here, we append all of that into our results vector, as we've done with previous queries. Then we check the length of that vector. Knowing that requirements must be unique by name, this should have exactly one result, otherwise it is an error. The unique constraint is enabled in the database itself. This just serves as somewhat of an extra layer of protection. The next step is to check the status vector. So we iterate it very quickly, and if we hit a requirement that matches in name to the one we specified by the user, then we check its status. If the status is true, then we print out that the requirement is complete. If otherwise, we will print that it is not complete. After that, we get the hours from the results of the query here, and we print that as well, listing that the required hours for the requirement are whatever the number is. Next, we print courses, and we have to query once again. This time, we're going to query with a join on all of the courses that are required by that requirement, using the course rec and course tables and the join clause here. So, if any of the courses names, or codes rather, are in the not taken list, then we print it prefixed with a minus symbol. Otherwise, we print all of the information with a plus symbol. The information that we are printing is the course code, its official name, as well as the number of hours, the credit hours, and what semester it's offered. Then, once again, we close our connection to the database. The next function to review is the lookup course function. This one starts in much the same way, where we start by opening up a connection to the database and setting up a cursor. This time around, we ask the user what the code of the course or the official name of the course they want to learn about is. We set up our results vector once again, and then we set up our query. We join the course requirement table to the course table on the condition that the course code has to match. And we also check for a match of either the name or the code. And because we have support for the course names matching, and because the physics classes based on the computer science course curriculum were both named general physics, we had to make a bit of an exception here in how we handled the length checking. Here we check to make sure that the course, the results are at least 1, because of course if there is nothing, the course must not exist, or at least not be in the database. The next step is we just take the top course and we store it into this course variable here, and then we use that to get all of the information in the output string, which is the first part of our output, where we list the code, the official name, the number of credit hours, and what semester the course is offered. In addition to possibly having duplicates in name, another thing we needed to account for is that a course may be in multiple requirements. So to account for that, we have this little statement here where we check the length again. If we have more than one requirement, we need this specifically to use as our range, because rather than simply iterate through, we use a range, so that way we can account for when we have our last of the requirements. So that way we can input commas to make it a little bit neater. So in the general case, we just add on to the requirement string. We concatenate the first sort of single quote, the name of the requirement, and then the second single quote. And if we are at the last requirement, or if we aren't yet at the last requirement, we'll add a comma and then repeat. Otherwise, we're done, and we append a new line. The next step is we're going to do something similar with the prerequisites. This time we have to do a query where we search through the prerequisites where the course code is equal to the... The next step is to handle the prerequisites. So the query we're going to use for that looks a little bit strange at first, but what we're handling is we're going to select the prerequisite code from prereqs, where course code is either what the user entered or what we got from the resulting course of their original query. This is because they could have searched by the name first, and in that case we wouldn't have a course code here to use. So we must account for that. Once that's complete, we append all of these into a prerequisite list, which functions much like the results vector. And then we use essentially the same general printing loop that we had before. First, though, we check to make sure that we don't have, if we have 0 prerequisites, we just enter none, and it's nice and easy. Otherwise, we do essentially the same printing loop that we used for the requirements. Then we close the connection to the database. The next function is to simply get all of the courses that are in any of the incompleted requirements. So to do this, first we have a flag here that we'll keep in case all the courses are already done and all of the requirements are satisfied. So first, though, we check through the status array and check to see which of them are incomplete, if any. That is to say, we check the flag true or false. If it's false, even once, then we set the done flag to false, so that this print statement here never occurs. And if we have at least one requirement that isn't met, we have to do something with that. So once we reach a requirement that is not done, we have to print a little prefix message that the requirement requires one or more of the following classes to be completed, and then we query on that requirement name and join it to the course table from the course requirement table based off of, again, the name of that specific requirement that we're iterating on. And we check if any of those courses are in the not taken category, then we will print them. Otherwise, they're ignored because we only are suggesting courses that are not yet taken. Then, of course, if we aren't done, we skip this and we close the connection to the database. The last function is the suggester function. The first part of it functions pretty similarly to the find needed function, but with a few remarkable differences. The first of which is that we check for the user input on what the semester is, as well as the number of credit hours they like to fill. Then we check through the status vector as we have done before, and we look for any requirements that haven't been met. And if we do find any, then we get all of the courses in them using the same query. After that, the main difference is how we handle that data. Rather than simply print all of the courses, we have to actually check them a bit. First, we have to check, make sure they haven't been taken yet. Then we have to make sure the semesters match, and that we're not taking a fall course during a spring semester or vice versa. We also have the condition that a course may be offered both semesters, in which case it passes. Then we use a can take flag here because the next stage is checking via a loop, and if it flags at any point in that loop, the course is disqualified. And this is on prerequisites. So we use the foreign key in the prerequisite table, which is the course code of a course, and we check through it and get all of the courses that are prerequisites to the given course we're looking at. And if any of those prerequisites occur in the not taken category, that vector we established at the beginning, then the course is immediately disqualified because we don't meet prerequisites. Otherwise, we can append it into our eligible list. After we've established what the eligible courses we can take are, we can go ahead and sort them by the number of hours that they'll take. We do this by reverse sorting with the key value of the credit hours. Then we can set up a running total and a basket vector that we'll use to store any of the classes that we have taken, or that we have chosen so far. And we use a greedy algorithm here to try to maximize the number of credit hours we can get towards requirements. So for every course that we're eligible to take, we check first to make sure that the number of credit hours we currently have in our basket plus the course we're looking at will not bring us over the desired number of hours. If that is the case, and it gets us to either less than or equal to the desired number of hours, we add it to the list and add that number of credit hours to the total. After we've done that, we can go ahead and start printing from the basket. We print the course code, the course name, and the number of credit hours. Alternatively, going back to the beginning, much like with the find needed, we have a done flag. If none of the requirements had any courses or none of the requirements were unfinished, none of this means anything because there's no sense in suggesting courses that are not required unless the user really wanted it. But at that point, they're probably not using this function or this software. So if that's the case, we simply can just print all requirements completed and no courses required. If that wasn't the case, then we go back and we check the total number of hours from our basket here, and we print the total. Then we close our connection from the database, and we are done. And with that, that concludes the code review for my final project. I hope this has given a bit of an illustration of some of the functionality that this software provides. And with that, have a nice day.